Travel back to October 30, 1961, a day that sent shockwaves across the globe. In a distant place called the Novaya Zemlya archipelago, something truly awe-inspiring happened. It was the unleashing of the Tsar Bomba, the most powerful bomb ever made. This colossal creation, crafted by the Soviet Union during the intense Cold War era, represented the pinnacle of destruction, capable of posing a threat to all life on our planet. But hold on, there's something even more terrifying, something that makes the Tsar Bomba seem small in comparison. Welcome back to this video, where we'll explore the realm of Neutronium, a weapon so incredibly perilous that it outshines even the Tsar Bomba. The Tsar Bomba stands as the most formidable and devastating thermonuclear bomb ever made. It packed a staggering 50 megatons of force, possessing enough destructive might to completely consume life within a 35-kilometer radius. But that's not where its devastation ends. It had the potential to inflict excruciating third-degree burns on individuals within a 100-kilometer range. Its mushroom cloud could even be witnessed from as far as 161 kilometers away. This explosive force was so immense that its blast and sound could reach up to 900 kilometers. There's no denying the sheer terror of the Tsar Bomba. Regrettably, for both this behemoth and humanity, something even more potent and malevolent looms on the horizon. Imagine a weapon with a core as tiny as a pinhead, yet possessing enough might to devastate our entire planet. This weapon blurs the line between reality and science fiction solely through its immense power. The key component we're talking about here is a neutronium core. Neutronium is a hypothetical substance made up entirely of neutrons, which are subatomic particles that, along with protons, form an atom's building blocks. Unlike protons with their positive charge, neutrons are neutrally charged particles and have much more mass. Neutrons can only exist within the nucleus of an atom, held together by a strong force. Alternatively, they can exist under tremendous gravitational force, much like a neutron star. That's why they are thought to make up the core of neutron stars. Without these conditions, neutrons have a short half-life of about 611 seconds or roughly 10 minutes. When a neutron decays, it releases a staggering 1 million electron volts of energy. But just how powerful is that? To grasp the incredible power we're talking about, let's simplify it by comparing it to something familiar: the humble TNT. TNT, short for trinitrotoluene, is a yellow substance known for its explosive nature. It was first created by a German chemist named Julius Wilbrand and was initially used as a yellow dye. About 30 years later, people discovered a new purpose for TNT as a potent explosive material used in industries, mining, and the military. Its stable composition and impressive explosive force made it the top choice for making explosives. In fact, it became the literal benchmark for measuring the explosiveness and destructive potential of bombs that came afterward. This is why we use the phrase kilotons or megatons of TNT to describe and gauge the power and sheer force of bombs like Little Boy in Hiroshima and Fat Man in Nagasaki. A single 1 kilogram stick of TNT holds an energy punch of 4.2 megajoules, which is like having 1 kilowatt of power for an hour, enough to run one household for an hour. Its heat energy amounts to 14.5 megajoules or 4 kilowatts per hour, which means it can provide an additional 4 hours of power for that same home. Now, while it's impressive that TNT could theoretically power a home for a few hours, it's dwarfed by the likes of the Little Boy and the Fat Man. The Little Boy, with its 15-kiloton explosion, packs a whopping 63 terajoules or 17.6 gigawatts per hour. That's enough to supply electricity to a small town with around 1,600 homes for an entire year. When it comes to heat, the Little Boy outdoes itself with an equivalent of 65 gigawatts per hour, which could easily power 5,500 homes for a year. But of course, the Little Boy isn't even in the same league as its bigger sibling, the Fat Man. The Fat Man can unleash 88.3 terajoules or 24.5 gigawatts, enough to provide power for 2,200 homes for a year. But let's be honest, using these bombs to power houses doesn't really showcase their true mind-boggling power. When you combine the might of both the little boy and the Fat Man, you're looking at the ability to completely obliterate a volume of water equal to 23 Olympic-sized swimming pools, which is about 60 million liters. If, in an alternate history, the US had dropped both the little boy and the Fat Man simultaneously, the potential loss of life would have been catastrophic. Together, they could have instantly vaporized 970,000 people in a single devastating event. Even though it never happened, it's chilling to contemplate the toll on human lives. Now consider the Tsar Bomba, which takes destructive power to a whole new level. Its potential for devastation is a staggering 1,400 times greater than the combined might of the little boy and the Fat Man. The Tsar Bomba could have vaporized an amount of water equivalent to 32,000 Olympic pools or approximately 1.35 million people. The Tsar Bomba had the potential to wipe out a significant portion of Earth's population. Thankfully, that scenario never unfolded. But it's crucial to understand that even the Tsar Bomba pales in comparison to the might of Neutronium. While a single neutron doesn't pack much punch, a whole kilogram of neutrons tells a different tale. A mere kilogram of neutrons can unleash the energy equivalent of 11.5 kilotons of TNT, similar to the power of Hiroshima's little boy. However, it's important to note that the resulting explosion wouldn't resemble those of nuclear bombs. This explosion occurs as the neutrons decay over their half-lives, meaning that the energy and destruction would be gradually released over a period of time. A kilogram of neutrons would go through 15 half-lives, which translates to roughly 2.5 hours in real time. Just picture all that destruction unfolding over a span of 2 hours. However, we also need to take into account the density of neutronium, which can significantly impact its power. Neutronium can be incredibly dense, allowing it to cram an immense amount of mass into a very small space. Imagine 5 cubic meters of neutrons weighing as much as 5.5 trillion kilograms, which is like having 900 pyramids of Giza condensed down into a tiny object the size of a marble. However, instead of being a solid physical object, this neutronium would exist as a degenerative neutron gas. It's worth noting that neutrons interact very weakly with matter, meaning you can only capture and contain them using an anti-gravity status field, just like the ones you see in your favorite sci-fi movies or video games. This technology is crucial for keeping the neutrons from decaying and causing irreparable damage. Until such technology is developed, it's unlikely that humanity will be experimenting with neutronium anytime soon. If technology were to advance to the point where we could contain neutrons and potentially weaponize them, the destructive potential is mind-boggling. Using kilotons of TNT as a measure, a mere spoonful of neutronium would have a numeric value that's almost impossible to comprehend. Instead, let's put it in perspective by comparing it to the Chicxulub impactor, the colossal asteroid that wiped out the dinosaurs. The Chicxulub impactor is estimated to have had a diameter ranging from 11 to 81 kilometers. Its catastrophic impact released an energy ranging from 1.3 to 58 yotta-joules. This colossal event formed a crater 150 meters wide and 20 kilometers deep, forever altering the Earth's landscape and leading to the extinction of the dinosaurs. Now consider 5 cubic meters of neutrons, which are 200 times denser in terms of energy than the Chicxulub impactor. The potential for death and destruction with this much neutronium is beyond imagination. Imagine dropping a 5 cubic meter marble made of densely compacted neutrons. The impact would create a crater that's a staggering 675 kilometers wide and 90 kilometers deep. The sheer force generated by this impact would be equivalent to the explosion of 2 million Tsar Bombas happening simultaneously. This tremendous force would obliterate the planet's surface in just a single second. Keep in mind that the energy released by decaying neutrons happens gradually over their half-lives, which extends for 14 hours. Every second during this process would release energy equivalent to 1.5 kilotons of TNT. In simpler terms, life as we know it would cease to exist. Fortunately, neutronium remains a hypothetical concept, and the technology to contain it is still years away. What are your thoughts on this video? Do you have any knowledge about other weapons of mass destruction? Share your insights in the comments section. And as always, don't forget to subscribe to stay updated and explore more content.